probabilities do not provide an absolute truth. One must therefore accept the highest probability available as representing what is closest to the truth. You just have to accept. Similarly, probabilities can be key in the establishment of faith in God. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah wa barakatuh. So we're still in chapter 2, the second section, advancing despite our restrictions. So when I cannot solve equations, whether because of my lack of knowledge, like insufficient data, or lack of ability, I'm unable to process all the data available, I can always resort to approximations or probabilities. I must therefore accept to take what is most probable as being closer to the truth. I now illustrate the use of probability in our life through some examples. So the first example, the fluctuation in statistical averages. So statistics are central to the development of financial institutions. In particular, when we look at the stock market, the one who can predict the evolution of the market is guaranteed to prosper financially. Stock market predictions are based on multiple factors, including past prices, price of related items, social trends, political moves, etc. However, knowing and taking each of these data into account is impossible because of the sheer number and complexity and their complex interdependencies. So to overcome this obstacle, the common trader can establish averages and look for recurring patterns, looking at trends. One then flies over the details to predict general trends and base one's choice on the prediction that is most likely to occur. So here again I have a small anecdote. A long time ago, I used to have to put money on the stock. Why? Because a friend of mine had money in the stocks and was making good money. Then he was making good money. He was like, yeah, you should try, go ahead. I tried and I lost. And I lost, meaning I tried, I had money, the stocks were going well until I got married. I went in my honeymoon, if you can call it this way. So we went for a trip with my wife, and during that trip, during that week, the stock plunged by more than 50%. It was one of the crash. And then a few days later, it plunged again. And I was like, okay, that's it for me. Funnily enough, before that, I had another friend who used to be a stock market analyst. And I asked him, like, what do you think of the stock market? And he told me, the best advice I can give you is just stay out of it. It's like if you're not going to invest long term with a large portfolio, just avoid it. If you're just to play around, just play something else. I guess that's a good advice. I should have taken it. But anyway, it's interesting to see how it goes. It's really like I stopped it also because it becomes like a drug. You start looking at the stocks, it goes up and down. You start developing yourself like softwares on how to predict and give you alerts when the stock reaches a certain price. When it goes down to a certain price, you can sell and buy automatically even. And I remember having my screens with just looking at the stock going up and down. And again, it was becoming like a drug. So it was not sane for me anymore. So I stopped it. Alhamdulillah, I stopped. So anyway, their job is to predict what it will become. So obviously it's a prediction. It has to be based on past events. So they use this past event to create trends. With complicated algorithm, you can predict somehow trends, but you cannot beat insiders' information. You cannot. So you can only ride the wave, but you don't see the wave before it is here, before it appears. So the second example, weather forecasts. Meaning it also depends on a trend, on predictions, but it's closer to our everyday life. So weather forecast. One of the objectives of probabilities is to predict future events. Past experiences allow one to establish trends and see patterns which are then put into equations. Weather forecast is one example. According to current conditions, such as wind speed, direction, temperature, humidity, one can use computational modeling to predict what the weather will be. But the current calculations, which already make use of the most powerful supercomputers, still cannot take into account every single factor. Thus, one makes use of approximations, such as replacing small and dispersed clouds by an overall higher humidity index. So you cannot model every single cloud, but you can have a generic humidity index to represent how dense the cloud is. Although the results are mere approximation, they are as close to the truth as it can be as far as the weather is concerned. The usefulness of these probabilities in that specific example is obvious, and it is common practice to base one's life choices on them, like what you will wear today, where you will go, if you are going to go on holidays or not. The third example, the wave function. So probabilities also dictate the way through which we understand the basic mechanisms of life. From a materialist point of view, life is an intricate succession of chemical reactions that take place between molecules. The fundamental building blocks of molecules are atoms. And a key characteristic of molecules and atoms are their electronic configuration. By electronic configuration, I mean the state of electrons around the nuclei. This electronic configuration is given by the wave function. Although the wave function is a specific mathematical formula, its application only results in probabilities. So wave function, again, that's a mathematical term. Think of the wave function as a barcode. When you have a product, you have a barcode. You go to the cashier, you scan it, it gives you the price. You use another tool, you scan it, it gives you number of kilocalories. You scan it, it gives you the origin of the product. So depending on how you scan, it gives you different information. The wave function is similar. It's like a barcode for that molecule, for that atom, or even for that particle. You scan it with, let's say, the Heisenberg equation, with another equation, and it gives you useful information, like the energy, for example. So wave function is just a mathematical tool that helps you characterize something, like a molecule, an atom, particle. All right. So when you ask through the wave function where the electron is, it gives you a probability of presence. It will never tell you where the electron is specifically, because it's too small, again, it's too fast. You cannot even see an electron. But you assume it will be somewhere here, more than there. And that's enough. So even though the solutions are not exact, these informed guesses, they are informed guesses, allow one to predict the overall shape of atomic orbitals. And when these atoms come together, it helps you predict molecular orbitals. And then it tells you how molecules are more likely to interact with each other. It's really powerful. They're only guesses, but they're extremely powerful. So consequently, this allows one to better understand how atoms join together to form molecules and how these molecules interact with each other. This theory forms the base of modern chemistry, which is so far quite successful. It's not perfect, but it's pretty good at what it does. So section summary. In summary, probabilities do not provide an absolute truth, but in the absence of more precise knowledge, approximations are the only tool in one's hand for attempting to understand the world. One must therefore accept the highest probability available as representing what is closest to the truth. You just have to accept. You need trust to accept that. This reliance on the highest probability is key in establishing scientific theories and advancing human understanding and control of the world. Similarly, probabilities can be key in the establishment of faith in God, as well as in justifying an Islamic conception of the world, as I will discuss in the next chapter. So here already you can see the parallel. In science, you need trust. You build convictions on probabilities. Like you believe the electron is somewhere here, and you believe that because it's somewhere here, the molecule will interact in such a way. You do the experiment, and it works. So that evidence confirms the belief, even though you never saw the electron. It's only an approximation, but that approximation at the end is enough to form conviction, to form a belief. So that's how you see, I hope you see the parallel with religion. You don't need to see God directly. If you have evidences that support that belief, it's enough. Scientifically, it is enough. So religiously, why not? It could be enough as well. جزاك الله خيرا. السلام عليكم ورحمة الله وبركاته.